Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen. Well, good morning, good afternoon, and good evening to all of you, because I can see that there are very many different people from many different places, and you're all welcome to this session today, where we're talking about mitigating noise from battery energy storage systems. So my name is Belén Gallego, and I am part of the REMAT by ATA Insights team. And what we do is we research the topics that sort of matter to you in your day-to-day work. And we find areas that require further information, clarification, and we create these webinars and also events that answer some of those questions or issues that require clarifications in businesses that are running renewable energy and storage systems across the world. We do many sessions. We have more than 100 every year. And this specific one came to me because I am currently doing research for an event which will take place in Poland next year. And it became very apparent that one of the issues that they have is pushback from the regulators in terms of the noise and requiring them further environmental research. And when I started asking developers whether this was an issue that they commonly faced, I very quickly could see that it was indeed quite a universal issue that people were facing across the world when developing battery energy storage system. But very little was spoken or was being produced in terms of information about how to handle this issue. And in fact, there was only like some information of some work being done in the US and in Australia, but practically no work in Europe and very little information as to how to overcome this issue of the noise in battery systems. And it's not a small issue, because as more and more battery systems move from industrial land into land that is closer to residential areas, it's becoming a bigger and bigger problem. So I made it my mission in the past few weeks to find experts that actually did have information and know-how about this topic, and I could bring them here so that they could speak to you about, how to handle it and where to start, what processes to follow, and so on and so forth. And it's my greatest pleasure to be able to introduce to you our two experts today. I'd like for them to introduce themselves so that you can get to know them a little better. First, Darrell, if you could please introduce yourself.
Yes, hi, good morning, good afternoon, and good evening, everybody. So I'm Darrell Furlong. I'm the Director of Energy Storage and Product Management for Wärtsilä, and looking forward to sharing what I've learned about mitigating noise on battery energy storage systems over the past couple of years. It's a relatively new topic, and it's been a very dynamic industry, and this has been the latest item that's really come up quite a bit. So thank you.
Thank you very much, Darrell, for coming and sharing with us. And also we have with us Kush today. Please, Kush, if you could introduce yourself.
Hi, everyone. I'm Kush. I'm from Hithium. So we're a battery manufacturer. We do cells, modules, and DC blocks. In applications engineering, we're working with customers every day, developers, utilities. Noise is, quickly becoming one of the top concerns, alongside alongside fire safety, things like domestic content. It's one of the key issues. And so, today, I'll be talking a little bit about what we've learned from working with developers. Some strategies we've seen work, also what we're doing from a battery manufacturer perspective to help mitigate noise. Because I think as these projects become larger and larger, you're trying to pack more energy into small areas, especially near residential areas. This is just going to become more and more of an issue. It's not going to go away, and so addressing it early is going to be the key.
Yeah, thank you very much, both Darrell and Kush. So you're looking forward to hearing from these two experts. And our aim really with this webinar is to give you a very good idea of how to start and how people before you have approached this issue. Just a little bit of a housekeeping, some housekeeping details. If I could ask you to please introduce yourselves using the chat on the side, and you're all welcome to introduce yourselves, because, it's good that, that you connect with other people that maybe are having the same issue somewhere else. I think collaboration is the key to maybe minimizing the amount of mistakes made, when progressing with these issues. And I mean, both Kush and Darrell have said it, this is increasingly an issue, and increasingly is going to be so. I mean, I know it's something that maybe wasn't spoken very loudly, perhaps trying to avoid, other people picking up on this issue, but is now really getting louder and louder, that we need to kind of pay attention to this. Just one more thing, please send your questions using the Q&A box at the bottom. Because it makes it much, much easier for us to manage it. And the way that we're going to be doing it today is that we are going to have a presentation by Darrell, then followed by a presentation by Kush, where they're going to get into their systems, and their advice. And then finally, we're going to take questions from you at the end. I think there'll be about 15 minutes at the end for questions. Okay, so all your questions, please send them through the Q&A box, and then we'll try to get to as many as we can at the end. So without further ado, Maria, if you can please take, yeah, and Darrell, if you want to share your screen and get ready. And whilst Darrell prepares his screen, just a reminder that, of course, we're recording this session. I don't think nothing is ever not being recorded these days. And you're going to have access to both recordings and also the presentations, in case you want to follow up in any of the details. And hopefully, this will be the beginning of this conversation. So, Darrell, I can see your presentation.
Okay, good. Yeah. So as I mentioned, I'm Darrell Furlong.
Go ahead.
Okay, good. Yeah, so I'm Darrell Furlong. Wärtsilä is a systems integrator for energy storage systems. What you see here in the diagram is one of our products that we call Quantum. And also in this photograph, I just want to point out there's some fans, which is one of the sources of noise in the system. And I'll be talking a lot more about that during the conversation. We do large projects globally. Australia, North and South America, in Europe are our main markets that we've been deploying into. And so about 2 years ago, approximately, we started getting questions from our customers about noise and noise mitigation techniques. As the energy storage systems have been moving closer to communities, this has been coming up more and more. And so in terms of getting permits allocated, we're starting to see requirements come up on noise mitigation or noise limits that you want to have for the site. And so this is kind of where it's been coming from lately, is really as this energy storage gets closer into residential communities, and even commercial parks have some noise limits requirements. We have a number of sources of noise. The battery energy storage system itself can be a source of noise. The inverters are also a source of noise in the sites, and transformers. These are the three major components. Cooling fans is one of the predominant sources of noise. These generate high frequency noise. So the fan rotation, the number of blades, how much air you're moving through the system can all kind of dictate how much noise is coming off the system. Dehumidifiers also have noise on them. In the inverters, you also have components that can vibrate. We call that tonal low frequency noise. So a lot of times the inductors that are in an inverter can start to vibrate, usually at a harmonic of the frequency that the utility is running at. So if it's 50 hertz for European, 100 hertz tone can be coming off the equipment. And so those are the areas where the noise is kind of coming from. And so what the task is how to kind of measure it and kind of mitigate it. One of the areas when I first started getting into this topic was confusion around how do you actually talk about noise? How do you, what spec do you use? And so there's a confusion between what we call sound pressure and sound power. So sound pressure is usually what you measure when you put a microphone out in the field and you pick up how much noise you can measure using a microphone. And depending upon where that microphone is located can really impact the measurement. So is it on the side of the unit? Are you sitting in front of the fan? Are you on top of the unit? So typically what you want to do in your specifications is talk about sound power, the amount of energy that is coming off of your equipment. So you take a lot of microphones, you surround your equipment around all the sides and on the top, and you create a measurement, what we call sound power, and that's what you want to see in the data sheets. That sound power is what's used by modeling software. When you do far field noise measurements, you kind of put in the sound power of each unit. So an analogy between sound pressure and sound power, we kind of look at temperature. So if you're in a room, and say you've got a space heater in your office or in your house, and you put a thermometer in front of it. So, where the heat is coming off of that device would be the temperature that you're measuring. And if you're in front of that heater, you would measure a higher temperature. But if you're behind that device, you would measure a low measurement for the temperature. So what you really want to know is how much heat power is coming off of that space heater. Is it 1,000 watts, 1,500 watts worth of heat coming off of that portable heater? And that's kind of what sound power is equivalent to, is how much energy in terms of noise is coming off. Then there's heat flow. How much watts is going into a given area? And the same thing with sound intensity. How much wattage is in a given acreage or something like that. So those are anyways the terms. So sound power is what you want to see on a data sheet. And a lot of times you don't see it. It will say a number like dBA, and it's unclear whether that's sound pressure or sound power. And so you want to ask that question, of the publisher of that data sheet, because there's a lot of confusion. I think right now the industry is starting to go to sound power, and you're starting to see that on the data sheet itself, where it will say the noise level and it will say sound power and so many dBA. Also, what you don't see on a data sheet, but what's important is the spectral content of the noise. And so usually between 50 hertz, 100 hertz, up to 10 kilohertz is the frequencies of interest. And so what I show here is a table, just an example measurement that we did on a piece of equipment in our lab, showing how much sound power is coming off of the device at these different frequencies. And so while we have an upper limit, say a total sum, here I show 79 dBA, that this is what all this would add up to as one limit, but you also have requirements for each frequency that you typically need to meet also. So spectral components and then the total power. What you see on a data sheet is usually only the total amount of sound power coming off of that particular unit. But you also want to keep a look at the spectral content. At the end of the day, what really matters is what we call far field noise. So when you're going into a community, you really want to look at what's the sound, that you're measuring at the property boundaries of that particular energy storage plant. And so you typically use far field modeling software. CADNA is a very typical piece of software used. We do this at Wärtsilä, and we will actually do far field noise modeling, for a project. And so we know how much energy is coming off each of our units. We will put that into our software, and then we will look at the boundaries of the particular project and come up with what we expect the sound pressure to be at those locations. And based on the ordinance requirements for that site, we then determine if we have to do something with the equipment to reduce the sound power coming off of each of the units. So this is the start of trying to figure out what you need to do in the devices. So this is very critical for any kind of urban planning and submitting of a permit to build a construction site, for energy storage system. And this is all recent, where the integrators are now starting to do this particular work and working with the project developer to get a good model on what the expected noise is going to be around that property. So for mitigation strategies, you want to look at, again, what is happening at the property boundaries. And in terms of mitigation strategies, you have a number of things at your disposal. You can change the topology of the property. You can plant trees. If the energy storage plant is in a valley, it tends to help mitigate the noise from going uphill. If it's at the top of a hill, it tends to make it worse in terms of noise getting down into the adjacent properties. You can also put up sound barriers at the site to kind of mitigate the noise propagating across the property. And then you also then actually can modify the equipment itself. And typically what you're going after is you're looking at the noise coming off of the fans. And can you reduce the fan speeds? Can you put more vibration material into the product for an inductor and minimize the amount of vibration coming off of that inductor into the actual enclosure itself? So you can put dampeners inside the equipment. These things all cost money. So you really want to be careful about just putting noise suppression in everywhere, because it may not be required for that particular site. And so you kind of work closely with your developer and the equipment manufacturer to see what's needed when you have a site that is really concerned about how much noise is coming off that particular power plant. So as I mentioned, mitigation strategy, source control. The best thing is to get the noise at the source and install quieter machinery, as I mentioned earlier, put in mufflers, sound barriers or baffles to kind of mitigate the noise. Path control is, as I mentioned earlier, put sound barriers or walls at the site to try to mitigate the noise. I actually did a project about 4 years ago at a community, actually in Massachusetts, where it was going into a residential community, and we ended up putting all the equipment inside a building. So we put the transformers, the inductors into an actual building to mitigate the noise. There was no other way to do it cost effectively. So that was a pretty brute force method, but it was going into a cottage community, and the residents really didn't want to hear anything coming off of the battery storage system, but they wanted the battery storage system there because they lost power a lot during the summer, and there was only one power feed going up to that particular area. And so they were using the battery storage system. It's kind of like a battery backup, if something should go down. And then also, you can use, in a factory setting, people use earplugs, soundproof rooms, and as I mentioned, building a building around the equipment to kind of create a soundproof room to absorb the noise coming off of the system. So anyway, you get these different strategies that you can follow for mitigating noise. In terms of key takeaways, the challenges are critical for noise management. There's no one solution that fits all. You have different strategies you want to follow. And again, you want to look at how you can do it cost effectively. There's a lot of things now being developed for new battery storage systems going forward at the start of the design to try to see how you can mitigate noise right at the beginning. And then also maybe adding a noise kit or a noise option so that you can use a kit to maybe reduce the noise coming off your product, 5 or 6 dB. It's usually what you try to get when you offer a kit. And then actual site design itself, using far field software, as I mentioned earlier, to see what you can do at the property level with, vegetation, dirt can be put around the equipment to try to mitigate noise coming off the site, et cetera. So that's kind of, my thought about what we do for noise mitigation. If you want to see more information about our product, there's a QR code here you can link or go to our website. So thank you.
Thank you very much, Darrell. Thank you very much for your presentation. If you can now just take away your presentation so that we can hand over to Kush. Excellent. So many questions, so little time. Some questions have started coming our way, but we'll deal with them at the end. So Kush, if you want to share.
Yeah, let me just get set up here.
Some very interesting questions about the parallels with the home computer industry and others. We'll get to them, but this is definitely very interesting. I can see
Okay,
your
can
presentation
you
and
guys?
I can hear you. Yes.
Okay, perfect.
Can you move it along because it's a little bit small and I just want to make sure that you can move it fine. It's fine. It's visible. It's no issue, but go to the next slide, please.
Yeah, sure.
Okay, perfect. Okay, yeah. You can start now. Thank you.
So hi guys, I'm Kush. I'm with Hithium. So like I mentioned, Hithium is a company focused fully on energy storage, and we manufacture everything from the cells right through to the modules to the BESS. We do work in utility, commercial, and residential, but everything I'm kind of going to be talking today is relevant to the utility sector, with larger scale BESS projects. And these are just some lessons learned that we work with developers and utilities every day. So these are some of the lessons we've learned, some things that we've incorporated into our product as well. And we're a pretty global company. I'm based in Houston. We have manufacturing facilities in China and soon in the US as well. So the thing that we've noticed, like Darrell mentioned, is that noise is increasingly becoming a big concern for developers. It tends to be that fire is a big issue. Noise also is, as well as things like tariffs with with the election that's just come up, and also domestic content. But these are some of the headlines. Just doing search from articles over the last year, where local communities or residents have pushed back on BESS projects because of not just safety but also noise. And so, it's not just about complying with regulations or authorities. It's really working with the communities, so that you can build a long-term relationship with them, because these projects are going to be there for 20, 25 years. The regulations kind of generally vary by location, the local authorities, how close you are to sensitive areas, how close you are to apartment buildings or maybe schools, as well as the time of day. So you might have tighter restrictions at night when people are sleeping, and so that could be a concern. If it's like a co-located with solar, when you are discharging into the evening and the night. But it's not just residential or commercial areas. Even in remote areas, you may have to comply with environmental regulations for wildlife protection. So it's the takeaway is that it's not something you can really ignore. And kind of everything I'm talking today is focused on the BESS, when they're in operation rather than construction. That's really a kind of different discussion when you're actually building these projects. Things like cranes, you got trucks moving in and out of sight. That's kind of a separate issue. So what are the sources of noise? Darrell already covered this in his presentation as well. But I think there was a comment in the chat about liquid cooling systems. And so these containers, most BESS nowadays use a liquid cooling system, but there's still a HVAC unit and a chiller, which is what actually provides the cooling. So that is the main noise source. You can see here for the Hithium container, this is on one side. So you have the chiller system on the side, with an inlet and the outlet for the air for the fans. The noise is very dependent on how you operate it. So operating at higher power and higher ambient temperature just means that you need to cool the cells more, which then in turn increases your noise. So for example, you're going to get higher noise for a 2-hour project in Texas than a 4-hour project in New York. The sound will vary manufacturer to manufacturer. Somewhere around 75 dBA at 1 meter is kind of it is right around the ballpark. The PCSs can be louder, not just cooling systems, but as Darrell mentioned, tonal noise as well, and humming from electrical components. So although they kind of generate more noise, you do have less of them on a site because you generally have 3 or 4 BESS per PCS. Transformers, again, can produce some electrical noise, and you'll generally have 1 medium voltage transformer per PCS and a high voltage transformer somewhere on the site. But that's less of a concern. And some of these are kind of site-wide strategies, and others are BESS specific. And so this is kind of a scale just to give you a sense of, well, what are, when we talk about dBA, kind of trying to put it into context. This is actual kind of noise levels from the Hithium 5 megawatt hour system. 1 meter away from the side of the chiller, I think you're about 78 or 79 dBA. And this is very directional as well. And so as you can see, if you're on the left side, so not facing the chiller, the sound is drastically reduced. As well as obviously the further away you get, the sound decays. But that kind of gives you a scale. So on the 1 meter away on the non-HVAC side, you're really at about ambient noise of an urban residence. But if you're on the side with a chiller, it can get very loud. It's kind of loud to the point where you'd have to shout to talk to each other. Hopefully this video is going to play. It's just a good and then that's 56. So obviously sound is not a linear scale, but that kind of gives you an idea of the numbers that we're talking about. And so before we get on to kind of mitigation strategies, well, what are some techniques we can use to measure sound and monitor it throughout the life? One important thing I think is to do a baseline study of what is the ambient noise at the site before you've installed any BESS. So that gives you some comparison data of before and after that you can use to assess the effectiveness of your noise reduction systems. It can also be a tool to use with the local communities to say that actually noise has been less than what was predicted, or noise is right around the ambient noise that it was before installing the BESS. So I think it's important to do this, and generally the way you do this is just set up sound level meters at various points around the site, various distances, and this should cover the full time period, again, day and night. And this way you can create this map of the site. And like Darrell was mentioning, there's various different softwares you can use out there to do this. When you come to a manufacturer, like Hithium or Wärtsilä will be able to provide you the sound data based on testing. And so it's important to work with the manufacturer, make sure you get those data sheets and make sure you understand them. And generally what we'll provide is A-weighted decibels. So these are kind of different from standard decibel levels in that the human ear is more perceptible to certain frequencies than other. And so the dBA scale adjusts for that. And so very low frequencies and very high frequencies that the human ear is not as good as picking up, they're given less weight than those middle frequencies. And so that's also something to look out for on these data sheets. This is just some pictures from a test setup. This is actually from the Hithium block noise testing. But we will place microphones around the container in different directions. Here you can see, so the point A is 1 meter away, B is 5 meters, you've got 8 meters and then 10 meters. and these are placed 1 meter above ground level. We'll generally kind of record for 30 seconds and then repeat for each different location, for each different fan and compressor speed. And so that we can give you across the whole range of powers, of container powers, that sound data that you can put into your model. And then, as Darrell mentioned, we not only give you the DBA, the overall DBA per location, but we also break it down into those frequency octave bands, so that you can find out which frequencies are dominant, and then you can target those specific frequencies. So rather than applying a broad brush sound mitigation device, you can target those specific frequencies that are most contributing to the noise. Some sites as well, you can implement real-time sound monitoring. So once the site is in operation, by having sensors placed around the site, you can then layer some analytics onto that to analyze any trends. Perhaps as the systems age, noise might be going up. Also triggering for noise spikes where you might be getting close to allowed limits, and you may have to take some actions based on that. If you can't do that, then, like I said, doing the baseline study and then every so often repeating the study so you can collect some data on how the noise actually is in operation and how it's evolving over time is pretty important. And like I said, not just overall noise, but also doing a frequency analysis. If you are implementing things like soundproof enclosures or walls, you might want to use certain materials which target certain frequencies, because that's going to be more effective. Like Darrell mentioned, these systems are expensive, so you want to use your capital wisely. Seeing as the HVAC system is the primary source of noise, that's one area you could target to try and reduce the noise. You can use things like special low noise fans. So I've got a picture here on the right which shows the blades with serrated edges. So this helps to reduce the noise and vibrations coming off of the fans. You can also use these ducted fan blades. Generally, larger surface area fans are what you want because they can spin at a lower speed and still move the same mass flow of air. Acoustic barriers are another way, essentially just walls to block noise. It's most effective to block noise at the source, as the noise decays. A small reduction in the noise at the source actually leads to a bigger impact at the site boundary. It decreases with the square of the distance. So like I said, just having a small impact at the source can have a big impact on the site boundary. So that's probably the first place you want to try and reduce the noise. Other things you can use is like brushless fan motors, which are quieter. This was a good kind of graphic I found off of a blog online, but it just shows the effect that actually placing barriers at the source or actually close to the recipient are the most effective ways to do this, rather than placing them equidistant between the source of the noise and where you're listening to it. And so that's really where you want to target first. Optimizing your site layout where possible. I know some of these sites are pretty space constrained, but if you can put the noisier equipment towards the middle of the site, great. If you can use natural buffers such as tree lines or hedges, and also orientating the BESS. For example, for us, we have all of the fans on one side. So if you can try and face that centrally into the site, that's a good way to drastically reduce the noise. We have a noise reduction kit that can be used. It's kind of bolts onto the side of the container. This does increase the footprint area of the container, and also cooling capability will be slightly lower. So this could be a great option in colder climates, or for lower power projects. This can also be a retrofit afterwards. Obviously, you don't want to get to the point where you're having to retrofit containers, but if you do need to, this could be a solution you could use. Darrell already showed us some great graphics on simulations, but trying to do those as early as possible and build those into your site design rather than designing your site and then figuring out what the noise is, because there can be certain areas where noise is channeling or it's amplifying, where you really need specialist software to do this. And also change, where possible, adjusting your operational strategy. This may be difficult with when you can charge and discharge. As the industry moves to longer and longer durations, this will actually be good for noise, that the batteries will be running at lower powers. And so that means that the batteries need less cooling, and that translates into less noise as well. And for us at Hithium, we are building a system, our next generation 6.25 megawatt hour container, which is for long duration. That has a lot of benefits, but in terms of noise, that translates into us being able to use a smaller cooling system, which takes up less power. So that's going to help us to reduce noise. We're trying to use larger flat fan blades as well as smarter fan speed control algorithms, which modulate the speed of the fan, such that obviously it's not running at full power all of the time, and trying to have more granular control of the fan speed. For this, we're targeting around 65 dBA at 1 meter. So despite having more energy because you're running it slower, that will reduce the noise. And so this may be something that you see more of in the industry, is batteries being designed specifically for long duration. And so hopefully that will help us trend downwards in terms of noise coming off these containers. Maintenance is something important and potentially overlooked. You'll have a maintenance plan that comes from the manufacturer, and you may also have your own maintenance procedures, making sure that the liquid cooling system is serviced as soon as possible so that it's efficient, so that the fans are having to work less hard. Any moving parts, making sure they're lubricated, any filters that need cleaning. This will kind of help over time. If you don't do these things, then noise is going to go up over time as the systems become less efficient. And one pretty novel idea that I haven't seen implemented yet, but we could see in the future, is the idea of a centralized cooling system. So rather than having each BESS having its own cooling system, separating that out into a separate enclosure and housing, where, like Darrell mentioned, we could place that into a separate building which has more effective insulation, or it's placed centrally on the site. That will help with noise. This is a complex solution in terms of the piping that will be required on site to circulate the coolant and the control systems. This also helps us to place more cells in the container because the HVAC system is taking up less space. So although I haven't seen it yet, this could be something that we see in the future, especially for large projects. And that was really everything I had. Feel free to shoot me an email if you have any kind of follow-up questions that we don't answer today, or connect with me on LinkedIn. But yeah, thanks everyone for listening, and looking forward to some questions.
Thank you very much,
Thank you
Kush.
very much, Kush.
A lot of information. I could hear myself twice now, but I think it's gone now. Really, really interesting, both of you. For me, this is a complete different topic. I'm not very used to speaking to people about this, and noise is such a, I suppose, different, when you're used to other issues, this is not typically an issue we have to worry about. So before we start with the questions, and there are a lot of those, I just had a question for the two of you. It's like the systems are becoming increasingly packed, right? Like there is more and more power to them, which means I assume that they're going to get noisier. And yes, there is talk about liquid cooling, but speaking to some of the manufacturers, they've said that actually you still need most of the equipment that requires noise if you have liquid. So could you just really clarify for me whether packing more powerful batteries is going to mean, and the liquid cooling, whatever other innovations will make the sounds go up or down? What can we expect in these trends? Do you want to start, Kush, and then we can ask Darrell?
Yeah, I mean, if you let's say you've got a 2-hour project and you're just using higher capacity containers, that probably is going to generate generate more noise because you've got more higher cooling loads that you need to provide. And so that is potentially going to generate more noise. Now, like I mentioned, if you're running at slower powers, that's going to help. So it's not purely, our container, we're going from 5 megawatt hours to 6 megawatt hours. So if you're running that at the same P rate, your noise may go up. But because we're going to be running it at slower powers, that means that our cooling load is reduced. And so this kind of also translates into some nuances in terms of how well is your thermal management system designed. Not only affects the efficiency of the cooling, but also the noise as well. How efficient are you at drawing the heat from the cells is very important. On the other question I think you had on the liquid cooling system, I think pretty much all manufacturers are now using liquid cooling systems, but you still have to have these HVAC systems to provide that heat exchange. And so that's not something you're going to be able to get away from. Liquid cooling is so much more efficient than air cooled, which is why everyone is moving away from air cooled. But you still do need these fans and these HVAC units on the side because you've got to cool the liquid that's going around the cells, right? So that's kind of my take. Maybe Darrell has some input on it as well.
Okay, Darrell, what about you guys?
Yeah, no, I would agree with that completely. The fans is really one of the major sources of the noise, and everybody's using liquid cooling, which is the most effective way to design these containers. But that liquid coolant that needs to be put through a radiator, and the fan is pushing air across that radiator to cool that liquid back down again. And so the size of the fans, the rotational speed of the fans, the number of blades on the fan, they all impact the amount of noise coming off the system and at what frequency that noise is emitted at. The inverters also are a source of noise, and they have fans on them also. And transformers sometimes will have fans on them also because they're typically oil cooled. And so you got to kind of look at all of that. And the more equipment you put on the site, yes, the more noise coming off of that site. It's all additive. So you've definitely got to model all of that when you're building a site. And I think Kush mentioned about the distance being a really important factor here. The further you can keep the equipment away from the property boundaries, the better, because that noise is reducing with distance. But if you're right on top of the property boundaries with the equipment, then you've really got to put in some noise mitigation strategies, for the property site itself, maybe walls, etc. So every site's a little bit different, and what is the most cost-effective solution is really what you're trying to get at the end of the day. And so that all kind of comes into play.
Okay, I have two more questions and I want to ask them because I think they're important and I haven't seen them in the questions. So I'm going to put them first. I hope the people in the audience don't mind. Your questions are important. A lot of them have been answered, but I think this is really key. Another thing I want to know is what is the difference from manufacturer to manufacturer? Can you see like significant differences in the noise levels that like developers should take into consideration there in the situation before they even think about mitigation? So
Yeah, I think that definitely. Sorry, go ahead, Darrell.
Okay, sorry. I was just going to say, for me, I really haven't seen a lot of variation from supplier to supplier on noise yet. There are noise kits that I think everybody's bringing to the marketplace, and that's really specific to the equipment itself that you're trying to mitigate the noise on. But I do believe everybody's taking a closer look at the noise coming off of the system as part of the product design itself to try to mitigate the noise. But again, it's an economic trade-off that you're looking at. So I think you're trying to have a standard product that is cost effective, and then you bring a noise suppression kit, added, which is more expensive, added value that you would then apply to the system. And then you got to look at the property itself and see what you can do at the property level.
Yeah, I think I agree, Darrell. I think there will be some slight variations from manufacturer to manufacturer. I don't know off the top of my head how much the dBA would be, probably around maybe less than 5 dBA difference. from what I've seen is that I don't think that would be the driving factor for you to choose one manufacturer over the other, because you've got really important things like degradation, cost, bankability. Those generally take precedence, I think, and that is usually how a developer will select their battery rather than noise being the forefront, because in general, there are ways to control noise, and they may be expensive, but it's probably cheaper to implement those than choosing the wrong battery in the first place, which degrades too fast or is too expensive or has safety issues. So I think that's what I've seen as driving developers' choices rather than noise. It's definitely important to put into your model, but it's probably not the first thing you think about.
Thank you. And just one more, like, what percentage, like, do you think that can be sort of like easily mitigated to difficultly motivated, but it can actually be mitigated in a site of the noise? From sort of 10% to 50%, I don't know, just.
That's a
That's a
good
hard
question.
question. Yeah, it's good. I haven't really thought of it that way. I think noise from fans is a little bit easier to mitigate than low frequency vibrational noise. At 100 hertz, for example, I found mitigating noise down at that low frequency is very challenging. Where at the higher with the fan noise at the higher frequencies, it's been a little bit easier to mitigate, mainly by just reducing the fan speed. So you try not to just run the fans excessively heavy all the time. You have variable speed, control on the fans. And usually at night, the environment is cooler than it is during the day. And so there's less cooling demand on the equipment if you're running it at night also can play a factor.
Anything to add, Kush, or you're.
No, I think Darrell answered that that pretty well.
Okay,
Thank
so
you.
let's go with the questions here. Okay, so this question, I'm going to start with Stefano that says, they talks about barriers and they say it's a possible solution, but what kind of barrier, he says, and how do you sort of mitigate the fire risks? Do you usually have issues with like fire brigades? So either of you want to take this?
Yeah, I think it's an interesting point, about using the acoustic barriers, and if you do have barriers between it for fire protection, whether they can double as acting as noise barriers, because if you do have barriers between containers, that is automatically going to act as a noise control system. And that depends on manufacturer to manufacturer. So, for example, with you'll have to look at their UL 9540A testing and their large burn testing. Some manufacturers, like Hithium, you'll be able to place the containers back to back and side to side to help you have a really dense footprint. But if you want to install those fire barriers, you'll have to spread the site out. But I think that's probably the way to look at it. If you are going to use these noise barriers, you are going to have to get buy-in from the fire department and assess things like the materials that are being used, flammability. But I think there's probably opportunity to say, well, if you're using these fire barriers in the first place, those can double as noise walls as well.
Okay.
Yeah, I would agree with that, but I have seen very, very few projects using fire barriers. I think in China is the only place I really know of where fire barriers have been used. Outside of China, I'm not aware of any site that I'm aware of that's used fire barriers.
Yeah, and I think now as the large scale burn testing becomes more and more of a requirement, you'll be able to get data from the manufacturer to show that if one container is on fire, it doesn't spread to the other ones. So yeah, like you said, those barriers are not going to be as common.
Yeah.
Is there any information regarding string versus central PCS? It's an interesting question. I wouldn't have thought of it.
Well, yes, I think when he says a string PCS, I'm assuming he's implying that the inverter is in the battery compartment also, or the battery container. So, less equipment at the site, fewer fans rotating should help. but again, it's really specific on the equipment design.
Okay. Can we talk a little bit? I don't know, Kush, if you want to talk, if you want to do let me know, because there are so many questions that I just, there is a question here about whether, you know, the questions, I just lost it. I don't know where it went. Whether the noises evolve over time. And you've mentioned maintenance, you know, if maintenance is not done properly. But other than that, I mean, the noise shouldn't go up or down, I guess, right? Like,
Yeah, that's right.
if properly,
Yeah, I actually answered
just
a question
maintenance.
during the chat here. Noise will not change over time if you do preventative maintenance. If the cooling system is running less efficient because of dust buildup on the radiators, for example, then the fans might have to be working harder or a little bit higher frequency. But I think all these sites have preventative maintenance where people go on site, you know, once a year or so and will, you know, kind of clean the equipment and make sure the radiators are dust free. But I have not seen anything where the noise has gone up over time. And I wouldn't expect it to go up over time.
Okay, another
Yeah,
one
I mean,
here. What?
like,
Sorry, Kush, go ahead. Go ahead.
Yeah.
it'll be part of your standard preventative maintenance program. Um, and you know, you want to do that not just for noise, but for you know, maintaining the batteries themselves. And so, you know, as long as you're doing those things, the noise shouldn't go up over time. And if you're not doing those things, you've probably got bigger problems.
Yeah, I agree. Yeah.
And Wagner asks whether BESS systems emit in lower or higher frequencies, in more intensity, because some mitigation strategies are better for high frequencies only. I don't know enough about this to be able to tell. So lower or higher frequencies.
As I was saying, higher frequencies typically coming from the fans, and the lower
Okay.
frequencies are typically coming from components vibrating, which would be in the inverter. The LC filter on the output of these inverters are very big, and they tend to vibrate at the second harmonic of the grid frequency, and that can be really hard to control because now you have to use a mechanical system to kind of put in think of like an engine in your car. It's on motor mounts that absorbs the vibration from the motor running, so it doesn't transfer into the frame of the car. So you have to start doing things like that with the inductors inside the inverters.
So Dwight asks, next to the battery, the noise is highest. In general, how far away do you have to be from the site so that the noise impact to be zero? Is there a rule of thumb that can be used? It's a bit of it depends on the noise, I suppose, but
Yeah, I haven't come across a general rule of thumb that we can use because I think it's going to be so dependent on equipment and also directionality and then the way that the site layout is and also the operation of the containers. And so I'm not sure. I don't have a rule of thumb really.
Yeah, I
I'm
don't
not.
either. And typically the equipment's placed a certain distance from the property boundaries for fire purposes, not for noise. So that if you have a fire that breaks out at the site, for example, you don't want that right on the property boundary. So usually there is a minimum distance that the equipment needs to be placed when you do a site, mainly for fire purposes. And noise is not really a consideration, at least not the projects I've seen.
okay. So, Kush, you mark these questions. Does adding sound barriers, mufflers affect performance of ratings of battery energy storage system that will affect warranty?
So I haven't seen it affect warranty, but I think you'll want to consult with the manufacturer because the manufacturer will have certain distances around the container that you want to maintain. For example, um, on the side of the doors, you need to have enough space to be able to swap modules, and on the side where the fans are as well, you know you may want to you know there may be certain access requirements or certain distance requirements that you want to make sure that you're not placing equipment directly there. But as far as I've seen, I haven't seen it affect warranty issues, but I think it's something that you should consult the manufacturer on when you design the site.
Yeah, I haven't
And
seen that
yeah,
either. It's really important that, you know, the hot air blowing off of a piece of equipment isn't pushed into the inlet of another piece of equipment. So that's probably the main thing you got to watch out for when you're designing the site, is that you're not heating up the air on the inlet to the fans from other pieces of equipment that are at the site.
Okay, let's continue then. Thank you. I see some layouts with grouping BESS containers side by side. Is that a good idea?
So I think this is dependent on which containers you're using. I think, again, that's a question that'll primarily, whether you place them side to side or back is probably primarily a fire safety question, in that you need to look at the manufacturer's unit level UL 9540A testing, as well as whether they've done large scale burn testing, because you need to make sure that if one container does have a fire, it does not spread to the neighboring ones. So they may have minimum space requirements, they may not. So I think that is primarily what is going to be driving that, as well as Darrell mentioned. There'll be certain keep out zones for the fan sides. What we do at Hithium is we have two different configurations, an A and a B, which are mirrored, which allows you to place these in blocks of 4 side by side and back to back, because the doors are only on one side. But I think the key thing driving that question is going to be fire propagation and making sure that you can stop that. And so that's something that will heavily depend on the manufacturer and also the AHJ that you work with.
Yeah, I totally agree with that. The manufacturers will give you a spec on how much space needs to be around the equipment, and you don't want to violate that. That's for sure. Yeah.
So unfortunately, we don't have a lot more time to answer questions, just a couple more minutes, but there is so many good questions that I also wonder. So, okay, one here says, are operational measures such as silent modes during nighttime when temperatures are lower going to become a main method to mitigate noise levels?
So that's what I've seen. I've seen at the sites where noise has been a concern, there's been 2 spec limits, one for night and one for day. And usually during the daytime, you're allowed to have more noise come off the site than you do at night. Also at night, for some reason, the noise tends to propagate a little bit easier, maybe because everything's kind of quiet. But and also during the daytime, the temperatures are typically hotter, and so the chiller and the fans are working harder also. So that's usually what's happening. Nighttime, the requirements are lower, but the temperatures are lower. So you usually can implement a strategy where you can implement and meet the requirements for nighttime operation and requirements for daytime operation.
Yeah, and I don't know if you've seen Darrell as well, but there may be some nuances as well when you do your simulations with the colder temperatures at night. Maybe having sound travel further with the density there. And so that's also something to bear in mind.
So
yes,
sorry, just the last question that I want, and I'm really sorry because there is some really good questions here, like the noise canceling technology. How does that work and can we apply it? No idea. But the last question, is noise related to plant power in general terms? So comparing a 0.5 C battery plant against a 0.25 C battery plant, noise levels are similar. Less noise per container, but more containers. I don't know. I didn't even understand the question. So question, you marked it. So
yeah. Typically, the higher the C rate, the harder the chiller is operating. So the noise would typically be higher for higher C rates, and it would be lower for lower C rates. That would be, I think, a general rule of thumb.
Yeah, and I completely agree. I think that there will be some balance, like you said, with these lower P's. If you do have more containers, then obviously that is gonna generate more noise. I don't know exactly where that kind of balancing point is, but yeah, in general, the faster you charge and discharge, you're going to heat up the cells more. You have to have the cooling system running harder, which means now the fans have to push more air, which means your noise goes up.
okay, and just one more thing. Someone asked here, if you put more systems that essentially make the same noise at the same level, does the noise go up or does it stay the same? This is a very good question. I don't know. Does it increase when you add more noise sources, even if all of them emit at the same level of noise?
So, yes, it's additive. Yeah, so the more equipment at a site, the more noise coming off of that site. That's right.
Okay. And that's it. Like for the questions, I don't think we really have time to answer anymore. But there is two things that I like to note that people have sent through. One, someone mentioned that in the UK, vegetation can't be used in the noise mitigation calculations, which I think is really interesting. The UK at least is a little bit of a cooler country or on the cooler side, so maybe that works in your advantage. I hope so. And then Fernando has sent, he says, as a general rule, minus 6 decibeliums when distance is double. So if the specs are 75 decibeliums at 1 meter, there will be 69 decibeliums at 2 meters, 63 at 4 meters, 57 at 8 meters, etc. That's just a general approach for understanding the range of sound propagation. Now, I don't know, I just wanted to read it out so that you can consider it. It's not, from you guys, but, there's all the people in the audience that may know a lot about these things. So I just wanted to thank you so much for your presentations and also for answering all those questions. There's been quite a few in total, as you could see, like we had like more than 30 questions. So thank you very much. Thank you very much, Darrell, and thank you very much, Kush. I'm really looking forward to doing other webinars further in the future where we look into this in more detail, because I am sure as time goes by, more and more know-how will arise and new technologies will come to the fore that we can be used on that. So thank you very much once again, and thank you very much also to the people who are in the audience. We will follow up with more webinars in due course, so do get in touch with us if you have any ideas for other things that could be useful to you, or if perhaps you could be part of the team that brings some more light into this. And for those who speak Spanish, we do have a webinar coming up also in Spanish. Thank you very much. Thank you, Darrell. Thank you,
Thank
Kush.
you.
See
Thank
you
you,
soon.
everyone.
Bye.